Hello, Alan. I'm thinking about if I don't want to do the reference counting and the allocating on the heaps thing. And I want to store the scale in the parabolic approximation. I have, what was it, 2080 Super? RTX 2080 Super. No. Not that I ever use it. So I want to add the scale to the parabolic approximation. But the parabolic approximation is going to be part of the library, not of the test. Meaning that it should not have to deal with plotting stuff. And one way to deal with that is to derive from scale and then add plotting stuff to the derived class, but then I can, or at least then I'm still being bothered by it in the library, because then this class needs to store pointers. If I don't want that, then what? Pretty sure that I need only one scale. Well, in this class anyway. Do something like scale something. Oh, scale. This is going to end up in, this does not do any plotting, right? Nope. Explicitly removed it. Difficult questions. I don't know. Why not? If you want to learn C++, then you have to start young, right? Like with everything that you want to learn at all. Scale. Okay, so my class has a scale. And then I don't have any plotting support. Well, no, I was going to add this here to the right namespace already. I'll just immediately move it to its own header. Still writing it. Let's just put it in the namespace. Gradient descent. Yep. So then we get the gradient descent scale here as well. And that is going to replace this scale, which has a plot and a second layer. But why? Just for these calls. Well, this is using stuff from the base class, which can no longer be a base class. Did I screw up compilation already? Call to implicitly delete the default constructor. Alright, I can't add a scale. At least the scale has to be initialized, really? What? Surely that is not true. There it is. Oh, this is the copy const. That's okay. So yeah, I can only make scales through create at the moment. But that's then going to change because I no longer want to use a boost intrusive pointer. No create. I'm not sure if I can still delete this. Was it that thing that I was complaining about? Anyway, this must be public. And then it's just a default constructor. We totally have a default constructor. What was it complaining about? Implicitly delete the default constructor. Because inaccessible. Okay, I made it accessible. And now it compiles. Good. Unbelievable. Oh no, I'm a scale. Scale for some reason. So I added the scale here, and then we'll want to manipulate that instead of let me see, this scale is this scale. Well, do I not have an accessor for the value here? Of course I do. Must have it. Oh, just this operator here. Hello, Divi Suthar. Sometimes I watch those movies where kids in a class present themselves to the new teacher, using all of them using absolutely non-pronounceable, difficult names. I get the same feeling. So all of you just come here with unpronounceable names just to tease me. Why can't someone just be called Carlo or something, John or something like that? No, I'm just kidding. Anyway, undo, redo. I guess I'm just going to add a accessor for the scale. I could make a const reference, but yeah, why not actually? Well, I have not convinced myself, but let's try it. Let's reference scale. So now I can call scale and access it, even though the whole thing hasn't been initialized or anything. Just sitting here, default constructed. But hey, I'm using scale somewhere. Temporary double there. History. Okay, I just need. I need scale. Okay, I'm going to pause here. I'm going to pause scale, which is now a member function of. It's something hopefully defined here. Yep, this one. The type of which was a scale const reference. So history add. Nobody knows where add is. You have to pause it down there as well. I guess my reference is live there. So if you take the absolute value of scale, that won't work. Let me see. Now it's going to access the scale on the parabolic approximation. No, music is better than music. Sometimes. So looking for my scale. There's another one. And we are around. Does it now compile? Right. Oh, that's a fast crash. Okay, it's just saying that scale should not be 0, which is 0 because I never initialized it. Hmm. Oh well. I should be able to delete this now, I think. I replaced all actually scale. Every place where scale is actually being used is now being replaced. So it should compile. Yep. That is good. And I commented out a shitload of stuff, which I now can fix, I guess. Well, here's one. It says maybe update the scale. However, that should be automatic as soon as the sample is changed. So this should be moved away from here into the place where we last changed what used to be new sample. Well, new sample is replaced with W, also because after changing W, well, the loss function and the derivative thereof at W are not calculated yet. But do I even want to do that here? the feeling that this early update is not necessary. It's my feeling. At the very least, I want to change it. So it is two different updates. Trying to understand when which is called. So in this case, it should be called if we are going in a direction where there is no extreme. So away from the extreme. And this one. This is called when we did not decide on which direction to go yet. And the fourth degree polynomial doesn't have any zeros. Can't even make that decision. Well, this one is called. We just jump to the vertex. And why is this so difficult? In the end, I think I just need one update, which just needs to be a lot more intelligent than the two that I have now. And the current update calls are all commented out. Let's just begin from the other end and add a call to a new update. So I have some kind of add here. Yeah, this one, add. This one. Add a new sample. Update the probe and then call on scale update. Now the very first time that we call this, it's going to be an update that actually should have been initialized, because we don't have anything yet. Don't have any samples. Yeah, this is already called with the previous and the current. In other words, there is nothing to do at all unless I have two samples, and then I can do something like initialize. Let's check what happens if I don't think maybe I'm probably not calling anything at all at the moment. So let's comment this out and make sure that we're not calling it. Oh yeah, I commented all of that out, right? So it's not being called. And then I'm going to add a new one, which is called update. Compiled. And that update needs to be implemented. Therefore, if I now run it, I can see from where we are calling it for the first time. Oh. Yeah, of course, that's the place where we call it for the first time. We have one relevant sample, that's the one I just added. Which has the value 12, so that would be here. That's this one. And also have the value for LW and the derivative. The second one is not initialized, and the scale is not initialized. It still has a boolean even. What the hell is the boolean doing here? Scale is still set at 0. Everything makes sense. Let's crash. It's the right moment to assert. No, I'm just kidding. Okay, so here we are calling it, and we should not have called it. That's basically the reason. Point. So if something, call it, the something being the number of relevant samples must be at least 2. It can, yeah, it can be at most 2 as well. Because otherwise I only have one thing and there's no scale at all in that case. Okay, so now no crash. Ta-da. Now we have 2 symbols, so no crash again. So now you have 2 relevant samples, namely the one at 12 and the one at 10.6. These 2. And then now I can initialize it. How do I know that it has to be initialized? I think I know it needs to be initialized because scale is 0. I need to get rid of a few things. My scale no longer should have an AI ref count. For start, let's remove that. See how long it keeps compiling. So I'm having a scale. Which should not be derived from AI ref count. Okay, yeah, minimum sample is remembering it only the scale yet. I think I should just remember the whole parabolic approximation. Simple, just points. To implicit deleted copy constructor. Core skill cannot be copied. Yeah, just want to make a copy of it. And then we do have to do something though. Hopefully the compiler will tell me about that as well. Copying is now allowed. Right, and the other thing was, I can't remember. There's something else I saw while running in the debugger. Up. Oh yeah, the hash sample layer. It's kind of silly. Yeah, I'm not sure yet. Anyway, I think that now we do have to do something that is equal to the initialization. And that is necessary. I can ignore this, I think. I just look at if the scale is 0. So at this point, if scale equals 0, then I want to do the initialization step, which I can copy from here. Parabola. Okay, where's my parabola hangout? I do have a parabola here. Is that the parabola that I need? Can't be. That can't be the problem, right? No, because that is the copied one. The previous second degree polynomial fit. We don't have any yet because I'm initializing it. So I think that this parabola has to be something I pass then. Pause it. Math quadratic polynomial. What am I doing? Is that really what I want to pass though? Yeah, probably. This is using previous and current. Mm-hmm. And I'll just do a return. Okay, what does the previous and current represent here? I guess just literally the last and then previous, the one before that. Are they symmetric? They're not symmetric. Well, actually, they are symmetric. I'm just looking for the largest one. So I need a one that is the furthest away from the vertex. And that is going to be one of the ones that I have, which is, or isn't. I completely forgot what was stored here. It's not stored here. So I have to pass that as well then. Seriously. And when I suddenly editing the wrong one, yeah, looks like it. Yeah. So editing this. Right, so compiles. Can run it again. Okay, now we get one step further. So now it initialized it, and we get the first problem. And then of course if we press space again, it crashes again. Because in this case scale is already set. So now we really must do an update. This is the same kind of update that I would do if I just jumped to the vertex. How can I detect that? Well, it's not easy actually. I have no idea. So in this case, well, that's what is going on in the test program at this moment. And then I want to do this. Yeah, I think that the way to distinguish this is to look at if the new sample is closer to or further away from the old vertex. I mean, if I jump to the vertex, and the difference should be 0 or almost 0. So definitely closer than the previous value. And then it's this case, yeah? So that's how I could detect that. And if you have only 2 relevant samples, it still should do an initialize. Otherwise, we call this update. Okay, I think that the otherwise means that relative samples is larger than 2. Because it's larger than 1. So I have to detect it, and then if relative samples equals 2, I have to do the same thing as we did before, namely still initialize. Otherwise, this update. How to deal with this drawing stuff? I guess I'll deal with that later. Okay, so I'm going back to see what I'm passing here. The same stuff. Initialize or update. Previous and current. Well, that's just the 2 last samples that I have. and the current approximation, which is already passed as well. I can't, however, make a distinction between relative samples equals to, or I have more of those. What? I guess I can actually. If we enter update while it is already 2 before I add it, then I know that it's more than 2. Yeah. What is this thing called? Scale.h. So this update is called from it's a bit long, but well. Yeah. Also need to know which is the last one. I'll pass next index and I'll call it previous index or something. Now you should have all the information. Let's see if it still compiles. So I want to detect if the new sample is closer. Yeah, it's kind of silly to pass the previous. I'm going to pass the current on. Current. Hello everyone. Kaira, yeah, I don't know, man. I have no experience with any of that. Guess opinions are heavily. There's multiple opinions about that. I chat on IC with C++ gurus who think Qt sucks, but I never used it myself, so I have no idea. If you have to choose between that job or being jobless, I would take it, of course. I mean, that's the better. It's much better to look for a job while having a job. Plus, you build experience for the next job anyway. But if you already have a nice job and now you're thinking about switching, then I don't know. Let's see. Okay, so now you have to make the decision, is this thing closer or not? So relevant samples, current sample index, dot W gives me the W value of the current sample. And I need the index of the current, the old problem. Let's call it previous. And then you can also do previous W, which is of course then the other index. And if that is the case, then I need to do the other update, except when, oh, I forgot. Well, except when I have, when this is false, I think. When this is false, you have to initialize it. I'm gonna expect that to be always be 0 though then. Is that nonsense? Maybe not very much nonsense. So that means that would be a good check anyway. And then I can do here, but the next step now, we do if the new W is closer to the vertex, and then we do the same thing as this update. That one. This one. And then this one has already been taken care of. So let's try to copy all of this. not really readable, is it? Scroll. What the heck is this? What is this? Nothing. Delete that one. Turn true. Those are not going to work. Which parabola is that? The one that is being passed, I suppose. A new parabola, yes. We are talking about previous and current again, which is starting to get annoying. Could have used that here as well. That's not true, actually. Shit. Well, I don't know. It's true for this one. This thing is doing the same as both. It just figures out which one is closer to the vertex. To pull-ish shit. Do I have another current? Not even. No previous then, I bet. Yeah, okay. That Vx and edge sample. Going to put that there. And then I'm going to replace this. I don't want to use that. This one is the furthest away. Wait a minute. And the other one was the closest, or what was it? I don't know anymore. the furthest away. Yeah. That's why it's called edge sample. Oh, right. I do need that. Oh, unbelievable. This gets more and more annoying. Plus, I want to stop. I've decided to go to the city, and I have to go there. I have to be there in 20 minutes. And I still wanted to take a shower and then put on the clothes on and walk 10 minutes to the bus and then take the bus. And we're going to be an hour late. Am I going at all? I could just not go. It's probably boring. Now let's go.